Space debris is a growing problem. As humanity continues to explore and utilize space, we leave behind a trail of discarded objects. These remnants of our ventures into the cosmos are not just floating aimlessly, they are a silent threat that looms above us. It consists of human-made objects orbiting Earth. These objects include everything from old satellite parts to discarded rocket stages. Each piece, no matter how small, contributes to the increasing clutter in our planet's orbit. These objects no longer serve a purpose. They are relics of past missions, abandoned and forgotten. Yet, their presence continues to pose a significant risk to current and future space operations. They range from defunct satellites to rocket parts. Some are as large as a bus, while others are tiny fragments. Regardless of their size, they all travel at incredible speeds, turning them into potential projectiles. Even tiny fragments of debris pose a risk. A small piece of metal, no bigger than a paint chip, can cause significant damage to a spacecraft due to the high velocities at which these objects travel. These objects travel at high speeds. Collisions can be catastrophic. A single collision can generate thousands of new debris pieces, each one a new threat to operational satellites and future missions. Space debris threatens our current and future use of space. It endangers operational satellites. These satellites are crucial for various services we rely on daily, from weather forecasting to global communications. These satellites are vital for communication, navigation, and scientific research. Without them, our ability to communicate, navigate, and conduct scientific research would be severely hampered. The debris field is getting more crowded. With each new mission, the risk of collision increases. The more crowded the space around Earth becomes, the more challenging it is to safely navigate and operate in this environment. This makes it riskier to launch new spacecraft. Each launch must carefully navigate through the existing debris, adding complexity and danger to space missions. The potential for catastrophic collisions looms large. We must address this issue. Efforts are underway to develop technologies and strategies to mitigate the problem. From satellite repair operations to space cleanup missions, the goal is to reduce the amount of debris and prevent future accumulation. Failure to do so could jeopardize our future in space. If we do not take action, the increasing debris could make space exploration and utilization unsustainable. Our dreams of exploring the cosmos depend on our ability to manage and mitigate this silent threat above. The number of satellites in orbit is increasing rapidly. In recent years, the space above our heads has become more crowded than ever before. This surge is largely driven by the advent of mega-constellations, which are networks of thousands of small satellites working together to achieve a common goal. Companies like SpaceX and Amazon are at the forefront of this movement, launching mega-constellations to provide a variety of services. SpaceX's Starlink project, for example, aims to deliver high-speed internet to even the most remote corners of the globe. Amazon's Project Kuiper has similar ambitions, seeking to bridge the digital divide by offering global broadband coverage. These constellations consist of thousands of satellites, meticulously placed in low Earth orbit. Each satellite plays a crucial role in maintaining the network's functionality, ensuring seamless communication and data transfer across vast distances. The primary aim of these mega-constellations is to provide global internet coverage. This could revolutionize the way we connect, making high-speed internet accessible to underserved and rural areas, and potentially transforming economies and societies. While this technology has undeniable benefits, it also raises significant concerns. The rapid increase in the number of satellites can lead to a range of issues, from space debris to the potential for increased light pollution, which could affect astronomical observations. The sheer number of satellites in these constellations is unprecedented. Never before have we seen such a massive deployment of space assets in such a short period. This rapid expansion poses challenges for space traffic management and collision avoidance. They significantly increase the density of objects in low Earth orbit. This congestion can lead to a higher likelihood of collisions, which in turn can create more debris, further complicating the space environment. This heightened density raises the risk of collisions. Even a small collision can generate thousands of pieces of debris, each of which poses a threat to other satellites and space missions. It also makes it more difficult to track and manage space traffic. With so many objects in orbit, ensuring that each satellite remains on its intended path becomes a complex and resource-intensive task. the long-term sustainability of these mega-constellations is in question. As we continue to launch more satellites, we must also develop strategies to mitigate the risks and ensure that space remains a viable environment for future generations. This includes improving satellite design, enhancing collision avoidance systems, and establishing international regulations to govern space activities. Space debris travels at incredibly high speeds. These fragments, often remnants of old satellites, spent rocket stages, or even tiny paint flecks, can reach velocities of up to 28,000 kilometers per hour. At such speeds, even the smallest piece of debris can pose a significant threat to operational spacecraft and satellites. Even a small piece of debris can cause significant damage. For instance, a paint fleck traveling at these high velocities can puncture a spacecraft's protective shielding. The impact can compromise the integrity of the spacecraft, leading to potential mission failure or loss of valuable equipment. When objects collide in space, they create thousands of new pieces of debris. This phenomenon is known as the Kessler syndrome, where the density of objects in low Earth orbit is high enough that collisions between objects could cause a cascade, each collision generating space debris that increases the likelihood of further collisions. This chain reaction can lead to a runaway effect. If left unchecked, it could render certain orbits unusable for satellites and space missions, severely impacting global communications, weather forecasting, and even national security. The International Space Station has had to maneuver to avoid space debris numerous times. These maneuvers, known as debris avoidance maneuvers, DAMs, are essential to protect the lives of astronauts and the integrity of the station. Each maneuver requires careful planning and coordination with ground control to ensure the safety of the crew and the station. In 2009, a defunct Russian satellite collided with an operational Iridium communications satellite. This collision was a stark reminder of the growing problem of space debris and the need for better tracking and management of objects in orbit. This event created thousands of pieces of debris. The aftermath of such collisions can linger for decades, posing ongoing risks to other satellites and space missions. The debris from this particular collision continues to be tracked and monitored to prevent further incidents. It highlighted the very real danger of space debris collisions. As we continue to launch more satellites and explore deeper into space, addressing the issue of space debris becomes increasingly critical. International cooperation and innovative solutions are needed to mitigate the risks and ensure the sustainability of space activities for future generations. The Kessler syndrome is a terrifying scenario. It occurs when the density of objects in orbit is so high that collisions become inevitable. These collisions create more debris, leading to more collisions. This cascading effect could render certain orbits unusable for generations. The consequences of the Kessler syndrome would be severe. It could cripple our space infrastructure, satellites could be destroyed, space exploration could become too risky. We must act now to prevent this scenario from becoming a reality. Section 5. International efforts, a patchwork of policies. The international community recognizes the threat of space debris. Several organizations are working to address the issue. The United Nations Committee on the Peaceful Uses of Outer Space, or COPUOS, plays a leading role. However, current international agreements are not enough. There are no legally binding regulations on space debris mitigation. Existing guidelines are voluntary, enforcement is weak. A more robust and comprehensive approach is needed. Section 6. The need for a global space traffic management system. We need a global space traffic management system. This system would track objects in orbit. It would predict and prevent collisions. It would also require international cooperation and data sharing. A global space traffic management system would improve safety in space. It would protect valuable assets. It would ensure the long-term sustainability of space activities. Developing and implementing such a system should be a top priority. Section 7. Technological solutions, cleaning up our act. Several technologies could help clean up space debris. These include lasers, nets, and robotic arms. These technologies could deorbit debris or move it to less congested orbits. However, these technologies are still in the early stages of development. They can be expensive and complex. More research and investment are needed to make them viable solutions. International collaboration on these technologies is crucial. Section 8. The importance of public awareness. Raising public awareness about space debris is essential. Most people are unaware of the issue. Educating the public can lead to greater support for solutions. We can use various platforms to educate people. Documentaries, news articles, and social media can all play a role. We must emphasize the importance of space sustainability. Future generations depend on our actions today. Section 9, Conclusion. Ensuring a sustainable future for space exploration. Space debris is a serious threat to our continued use and exploration of space. The problem is growing. The consequences of inaction are significant. We need urgent action. By working together, we can address this challenge. We can develop international regulations. We can invest in innovative technologies. We can ensure a safe and sustainable future for space exploration. The time to